So this video is on solving rational equations. Let's go ahead and start off with an example. We've actually done this before. 2a over 9 minus 1 over 6 equals a over 9 plus 1 over 6. So we have an equation that has fractions, right? What do we do when we have an equation that has fractions? Yeah, we get rid of the denominators. How do we get rid of them? We find the LCD. What's the LCD for 9 and 6? Yeah, 18. So now we're going to multiply each of the fractions by 18. So each fraction gets an 18. Just write it next to each numerator. Now we're going to reduce. 9 goes into 18 twice. 6 goes into 18 three times. So you cross out the 9 and 6 and then put the number next to the 18 while crossing out the 18. So 9 goes into 18 twice. 6 goes into 18 three times. And now we'll simplify. 2 times 2a, 4a, and then 3 times 1 is 3. Keep the minus sign in the middle. On the right hand side, 2 times a is 2a. 3 times 1 is 3. Move the 2a to the left hand side and the negative 3 to the right hand side, so you should get 2a equals 6. Divide by 2, and we get a equals 3. We'll do a check. It's kind of a pain in the butt, but we'll do it anyways. It's up to your teacher if you're required to show a check on a problem, maybe on a test. I would definitely do a check to make sure that you don't make any mistakes. Okay, so plug in a 3 everywhere you see the letter A, and then work out each side, and you should get the same number on both sides. That's what we're doing. We're just seeing that when you plug in the number, you'll get the same value on each side of the equals. That's it. Okay, so we've done this previously, right? So rational expressions have restrictions. Restrictions are values for the variable which would make the fraction undefined. So this first example, 3 over x plus 5, x cannot equal negative 5. It would make that fraction undefined. The second example, 3 plus 2x over 4x, x cannot equal 0. Again, it would make that fraction undefined. Here's our procedure for solving fractional equations. Number 1, determine any restrictions for the fractional equation. Number 2, find the LCM. Number 3, multiply all terms by the LCD. 4, solve the equation. 5, compare the answers to the restriction. If the answer is a restricted value, cross it out. If all answers match restricted values, then there is no solution. Okay, so here's our first example where the denominator has a variable. In the first example, the denominator did not have a variable. Now we do. So step 1, state the restrictions. What number would make any of these denominators 0? And that answer is 0, right? 4 times 0 would make it 0. Also, 2 times 0 is 0. So that's our only restriction, that x cannot equal 0. Whatever we get for an answer for x, it's fine as long as we don't get 0. Okay, we need to also find the LCD. So the LCD for 4, 3, and 2 would be 12. And then we have a variable of x, so we take the highest exponent of the x, which is just 1, so the LCD would be 12x. Now we're going to multiply all terms by the LCD. So 12x is written in front of each fraction. Now we can reduce. In the first fraction, the 4 and 12 will reduce, and the x's will cancel. In the second fraction, the 12 and 3 will reduce, but the x does not cancel. And on the right-hand side, the 2 and 12 will reduce, and the x will cancel. So you should end up with 27 plus 4x equals 30. Now subtract 27 on both sides, and then divide by 4. So our answer is 3/4. Okay, let's do a check. It's also important to note that that answer is not one of our restrictions. Our restriction is only x equals 0, so this is great. 3/4 is our solution. So plug in a 3/4 everywhere you see an x. A little bit of work here. On the left-hand side, 4 times 3/4 is 3 because the 4's cancel. And on the right-hand side, 2 times 3/4. 2 and 4 reduce, the 2 cancels, and 4 becomes a 2. On the left-hand side, you could add 9/3 plus 1/3, which is 10/3. And then on the right-hand side, 5 divided by 3/2. I didn't show it, but you could write it's a complex fraction. So it's 5 divided by 3/2. Keep change flip. 5 times 2/3. And you should get 10/3 also. Okay, here's our next example. X plus 1/x equals 10/3. Any restrictions? Yes. Again, x cannot be 0. 1/0 would be undefined. So that's our only restriction. X cannot equal 0. LCD? LCD would be 3x. So now we're going to multiply each fraction by 3x. Even the first x gets multiplied by 3x. That's a fraction. It's got a 1 on the bottom. So each term gets a 3x. So now we're going to simplify that. 3x times x is 3x. In the middle, the second fraction on the left, the x's will cancel, but the 3 will remain. And on the right of the equal sign, the 3's will cancel, and the x will remain. So 3x squared plus 3 equals 10x. So now we have to solve this. Whenever you see an x squared or an x cubed, we have to get everything on one side, write it in order, and then do some factoring. So subtract 10x on both sides, bring the 10x to the left-hand side, and now we could factor that. 3x minus 1 times x minus 3. You might want to pause and make sure you work out the factoring there. Now set each factor equal to 0, so we have two answers. The two answers are 1/3 and 3. Do either of these numbers make the denominator 0? No. So they're both good answers. I'm not going to do a check, but if you're going to do a check, you want to do two of them. First do 1/3 and then 3. You should at least know how to do a check. Most instructors don't require that you do a check on homework, but it's a good idea to do on a test. That way you know if you got the correct answer. Okay, example 4. Solve 3 over x minus 1 equals 2 over x plus 5. First thing is to state the restrictions. The fraction on the left, x cannot be 1. Because if x is 1, 1 minus 1 is 0, and we get 0 in the denominator, which is undefined. So the restriction for the fraction on the left of the equal sign is x cannot equal 1. How about for the fraction on the right of the equal sign? Right, x cannot equal negative 5. So those are our two restrictions, positive 1 and negative 5. Okay, second step. Find the LCD. Well, the LCD would be both denominators, x minus 1 and x plus 5. So we're going to multiply both terms by the LCD. So x minus 1, x plus 5 on the left, and x minus 1, x plus 5 on the right. Now we can simplify, so cancel. So on the left-hand side, the x minus 1's cancel. On the right-hand side, the x plus 5's cancel. Now on the left, distribute the 3, and on the right, distribute the 2. There's no x squared, so we don't have to factor. Just get x by itself on the left-hand side. So we have x equals negative 17. And that answer is not equal to our restrictions, right? As long as we don't get negative 5 or 1, we're good. If we did get x equals negative 5 or x equals 1, we would have to cross it out. So if we got x equals negative 5, we would cross it out. It would be no solution. If we had two answers, and let's say we got negative 5 and 12, the negative 5 we would have to cross out, but the 12 would still be a solution. Okay, I'm not going to show a check, but you could if you want. If this was a test, I definitely would probably show the check. Another way of doing this problem is by cross multiplying. So what we did on this problem is we solved by multiplying both sides of the equation by the LCD. So cross multiplication is where you multiply the top number on the left fraction times the bottom number of the right fraction, and then you put an equal sign, and then the top fraction of the right fraction times the bottom number of the left fraction. Hope I said that right. Another way of saying it is the product of the means equals the product of the extremes. Okay, so let's do it. So you multiply diagonally 3 times x plus 5, and you put equals 2 times x minus 1. You can see that we're getting the same result. Distribute, get x by itself, you still get the same answer of negative 17. So this only works when there's one fraction on one side and one fraction on the other side. Okay, here's our next example. X over x minus 2 plus 1 equals 8 over x minus 1. State the restrictions. So for the fraction on the left, what can x not be? Right, x cannot equal 2. And the fraction on the right, what can x not be? X cannot equal 1. So 1 and 2 would make either of those denominators 0, or one of those denominators 0. And when a denominator is 0, it's undefined. So we have two restrictions. X cannot equal 1 and x cannot equal 2. Let's find our LCD. So our LCD will be both denominators, x minus 2 and x minus 1. Multiply each fraction by the LCD. Don't forget to multiply the 1 by the LCD as well. 1 is still a fraction, it's 1 over 1. Now we can do some canceling. So the x minus 2's cancel on the left, nothing cancels in the middle, and the x minus 1's cancel on the right. So now we could distribute the x, so it's x times x minus 1 plus 1 times x minus 2, x minus 1. You're going to have to FOIL the x minus 2, x minus 1 equals 8 times x minus 2. So distribute the 8, that'll give me an 8x minus 16. So x squared minus x plus 1 times x squared minus 3x plus 2 equals 8x minus 16. Now that 1 in front of the parentheses, well, 1 times anything is the same thing. So you can disregard the 1. Then add like terms. 2x squared minus 4x plus 2. As soon as you see the x squared, that means you have to get 0 on the right hand side. So subtract the 8x and add 16 to both sides. Okay, factor. Again, as soon as we see x squared, that means factoring. Factor out a 2 from the left hand side. And then factor that trinomial. It's a perfect square trinomial. So it's x minus 3 times another x minus 3. Solve those equations. It gives us only x equals 3. X equals 3 is not equal to one of the restrictions, so we're good. Check. Here we showed a little bit of a check. So 3 over 3 minus 2 plus 1 equals 8 over 3 minus 1. So we get 4 equals 4. It works. We feel good about our solution. We can move on. Okay, here's example 6. Negative 4 over x squared minus 9 equals x plus 1 over x squared plus 3x. Before we could state our restrictions and find our LCD, the denominators must be factored. So the fraction on the left, it has a denominator of x squared minus 9. You should be able to factor that quite easily. X squared minus 9, what does that factor to? That factors to x minus 3, x plus 3. And how about the denominator on the right, x squared plus 3x? It has a GCF of x, so factor out an x. And that's x times x plus 3. So we have factored both denominators. Now we can state our restrictions and find the LCD. What are our restrictions? Well, x cannot be 3. It cannot be negative 3. And one more number. That x that's on the right fraction cannot be 0. So when we set them all equal to 0, we get x equals 0. X equals 0. negative 3, and positive 3. Okay, LCD. So the LCD is going to need an x minus 3, an x plus 3, and an x. Multiply all terms by the LCD, so multiply that on both sides. Okay, now we can do some canceling. On the left-hand side, an x minus 3 and an x plus 3 will cancel. On the right-hand side, an x and an x plus 3 will cancel. Okay, so it's negative 4 times x on the left-hand side. That's all that's left. On the right-hand side, there's an x minus 3 that's left, and we have to multiply that by x plus 1. I put parentheses around the x plus 1 because when I multiply, I need to FOIL. On the left-hand side will be negative 4x, and on the right-hand side, x squared minus 2x minus 3. As soon as you see the x squared, that tells you you need to get 0 on one side, so I'm going to add 4x to both sides. And now we could factor that trinomial. Set each factor equal to 0 to solve. So we've got two answers. We've got x equals 1 or x equals negative 3. Now negative 3 was one of our restrictions. So that means we got to cross it out. So we only have one answer left, x equals 1. You should do a check. I didn't show the check. Again, if it was a test, definitely do it. Not a test, if your teacher doesn't require it, up to you. All right, last example. Before we could state our restrictions and our LCD, we need to factor the denominator on the right-hand side. And that factors to x plus 8, x minus 4. That's not bad because if you look at the fractions on the left, we have the same denominators, an x minus 4 and an x plus 8. So what are the restrictions? The restrictions would be x equals 4 and x equals negative 8. And our LCD would be x plus 8, x minus 4. Okay, so now multiply that by each fraction. Cross out any like factors. So on the far left, the x minus 4s will cancel. In the middle, the x plus 8s will cancel. And on the right, both factors cancel, the x plus 8s and the x minus 4s. So now distribute the x, distribute the negative 2. Be careful, it's not 2, but a negative 2. And then bring down the 63 on the right-hand side. Again, we have an x squared. That means we have to set it equal to 0 so we could factor. So add the 8x and negative 2x and then subtract 63 on both sides. So you should get x squared plus 6x minus 55 equals 0. Hopefully that factors. Yes, 55 is 5 times 11 plus 11 and a minus 5. That gives us two answers of a negative 11 and 5. Neither one of those numbers match any of the restrictions. You could check. Both of them should work. I didn't show it, but you can if you want. All right, that's it. I'll see you here for the next video.